Welcome to Mobitron configuration video. We're going to look at how to configure and activate a device for transport. First, log in to Cargo Connect. Once logged in, check if the Setup Device feature is available in the menu. If this feature isn't accessible, you'll need to purchase a license key that includes this functionality. Alternatively, contact an administrator to provide access to a license key with this feature. Next, connect the device. Once connected, you'll be directed to the connection center. If this doesn't happen automatically, click on Connected in the menu at the bottom of the screen. You'll see several quick access buttons appear. The button we need is called Setup Device. This is where we'll download parameters and activate the device. Upon entering the Setup Device menu, the serial number of the device to be configured will be displayed at the top. This confirms that you're working on the correct device. Now we've reached Step 2, Parameters. Here, you'll start by entering a project name. The project name is important because it will remain associated with the device. This means that any measurement data collected will be organized under the project in the project view. You can include one or more devices in the same project, allowing all data from these devices to be grouped together. Data can be uploaded manually, or if the device supports GSM, it can send data automatically. Click Create to create the project. You can also add a description for the device. This description might include details like where the device is installed or what type of product it is monitoring. Here, you'll see several tabs visible. These represent the sensors available on the device. If a device doesn't support certain sensors, those tabs will be hidden. To access all tabs, you'll need a model equipped with all the features. Proceed to the Acceleration tab. For each sensor, you can choose to enable or disable it. In this example, we'll activate acceleration to measure and record movements. The device has 3 axes, X, Y, and Z, and you can enable or disable them individually. Each axis has a recording level and an alarm level. Any acceleration that exceeds the recording level will be saved on the device. If the alarm level is exceeded, the LED will go from green to red. Additional functions can also be triggered when the alarm level is reached. You can adjust the levels for each axis. The duration is only linked to the alarm level. When an acceleration exceeds the registration level, it will be stored in the device. For the alarm level, the customer can choose not only the acceleration in G-force, but also how long the acceleration must last to exceed the threshold for the alarm level. The alarm will only trigger if both the level and the duration thresholds are exceeded. If you don't require a duration threshold, you can set it to 0. You also have the option to increase or decrease the alarm level as needed. The device includes 12 low-pass filter options. These filters determine how acceleration data is calculated and displayed in the measurement results. The low-pass filter reduces the risk of misjudgment by ensuring that the measured value remains stable over a longer period. A commonly used filter value is 29.5, and we'll select this for the current setup. There is also an option called Detail Vibration Analysis, which records the entire vibration curve, also known as shock curve, without applying low-pass filters. This is useful if you want to perform a more detailed analysis of acceleration data. With detailed vibration analysis, not only the summary of the shock, but also the complete measuring cycle is recorded and stored. In this case, we'll set the level to 1 G-force. It's important to note that you cannot go below the highest recording level already set. As mentioned earlier, an alarm level can also be configured. We can also trigger additional events if the alarm level is exceeded. For example, if an impact exceeds 2.5 G on the X-axis with a duration of 20 milliseconds, it will trigger the alarm. Additional features can be enabled when the alarm level is reached, such as recording angles, logging GPS positions, or transmitting data. Next, we move on to temperature. You can enable or disable temperature monitoring. Set the logging interval, which defines how frequently temperature readings are recorded. In this example, the interval is set to 6 hours. You can also define an alarm level, which can trigger additional actions, such as sending data or turning the device's LED from green to red when the temperature exceeds the defined threshold. minimum and maximum level are configured for temperature. In this case, the range is set between -5 degrees Celsius and +20 degrees Celsius. If the temperature reading drops below -5 degrees Celsius, the LED light on the device will change from green to red. Additional functions can also be triggered when the alarm level is exceeded, such as recording GPS positions or sending data. Next, we move on to humidity. Humidity monitoring is activated with a logging interval set to 6 hours. The alarm level is defined within a range, for example, between 20% and 70%. When the alarm level is exceeded, GPS and GSM functionalities can be enabled to log or transmit the data. After configuring humidity, we proceed to the angle settings. Activating the angle feature allows the device to record angle measurements when acceleration surpasses the set recording threshold. As mentioned earlier, a recording threshold has already been defined for each axis. Similarly, an alarm level can also be set for angles. If the alarm level is exceeded, the LED light on the device will change from green to red. Alarm levels can be customized for each axis, and additional functions, such as recording GPS positions or transmitting data, can also be triggered when an alarm level is breached. The reference angle feature can be enabled, allowing the device to automatically detect its mounting position upon startup and use that position as its reference. This means the device must be properly mounted before it begins measuring for the reference angle feature to work correctly. If you want to use this feature, you need to enable it during configuration. Next, we move to the Triggers section. Here, you can see some of the settings already configured for individual sensors. For example, if the alarm level for acceleration is exceeded, the system is set to record the angle, log a GPS position, and send data. In this section, you can also configure additional actions for each sensor. For instance, if the temperature exceeds its alarm level, you can enable humidity monitoring to record a humidity reading in response. You also have the option to disable functions you do not wish to use. Once all trigger settings are configured, click Next to proceed. In the next step, you'll choose how to start the device. There are 3 options. You can set a specific start date and time, start the device immediately, or start it manually with a button press. A manual start is useful if you're unsure when the shipment will begin. Additionally, you'll specify how long the device should remain active. In this example, the runtime is set to 365 days, but you can adjust this duration up or down as needed. At this stage, you can configure the GPS and LTE settings. This involves selecting the intervals at which GPS positioning data will be recorded. By clicking on the pencil icon, you can adjust these intervals. For instance, you might set the GPS to log data every 4 hours. You can also configure LTE settings to determine how frequently the device will send data. In this example, data transmission is set to occur every 12 hours. Since GPS positioning and data transmission are also triggered when alarm levels are exceeded for any of the sensors, this scheduled transmission serves as a backup in case no alarm levels are triggered during transport. At the top of the screen, you can verify whether the current settings will allow the battery to last for the entire transport. In this scenario, the device is equipped with GPS and GSM. For GSM, we strongly recommend, and nearly require, the use of SAFT-14 batteries from the manufacturer. This specific battery type is appropriate for the model in use. In the battery check section, a red circle with a cross icon indicates that the current settings will deplete the battery before the transport is completed. In this case, adjustments are needed to ensure the battery lasts for the entire transport. You can either modify the measurement period, which is the duration the device is set to measure, or adjust the functionality of the measurement sensors. For example, you might reduce the data transmission frequency to once per day. With this adjustment, the system indicates that the battery usage would be reduced to 97%. It's important to remember that the number of times acceleration thresholds are exceeded during transport cannot be predicted. This uncertainty makes it wise to leave some battery margin. In this example, I would also adjust the GPS settings, which further reduces the estimated battery usage to 79%. Adding recording block feature can be used for transports involving different modes, such as a shipment that starts by road, continues by sea, and then returns to road transport. If you know there will be no possibility for GPS positioning or GSM LTE network to transmit data, you can disable these functions. To conserve battery during this period, it's practical to disable these functions. By selecting Add Recording Block, we can define separate configurations for each phase. For instance, the first recording block represents the initial road transport phase. The transport settings are configured here. For instance, we might set the first block to run for 30 days. After this period, the next block would cover the following 200 days. During this second phase, flight mode is activated. This means both GPS and LTE are disabled, not only for scheduled intervals, but also for alarm-triggered events. For example, if thresholds for acceleration, temperature, humidity, or angle are exceeded, the device will not attempt to record GPS positions or send data via LTE. The final block starts after 230 days and run for approximately 20 days. In this phase, GPS and LTE are reactivated. Reviewing the settings, we can see that disabling GPS and LTE during the second phase reduces battery usage significantly. The device is now estimated to consume only 26% of the battery, simply by disabling these functions during periods when they are unnecessary or unusable. Once the settings are finalized, click Next. You will then see a summary of all the configurations. The summary includes the chosen start method, which in this case is through a button press, and confirms the total runtime of 250 days. It also displays the project name, the serial number of the device, and the description provided earlier. Additionally, the recording and alarm levels for acceleration on the X, Y, and Z axes are listed. We are using a low-pass filter set to 29.5, and the recording level for detail vibration analysis is set to 1G. The sampling interval for temperature is configured to 6 hours, with alarm levels set between -5 degrees Celsius and +20 degrees Celsius. Humidity is also sampled every 6 hours, with alarm levels set between 20% and 70%. For angles, the alarm levels are configured at 20 degrees, 10 degrees, and 20 degrees for the X, Y, and Z axes respectively. The reference angle feature has been enabled, which means that when the device starts, it will automatically detect its mounting position and use it as the reference angle. It is important that the device is mounted when it is activated and starts measuring. If acceleration exceeds its alarm level, the device will trigger actions such as recording angles, logging GPS positions, and sending data. Similarly, when alarm levels for temperature, humidity, or angle are exceeded, GPS and LTE functions will also be triggered. In the configuration, the device is set to operate in 3 distinct phases. During the first phase, which lasts 30 days, the device will send data once per day and log GPS positions every 8 hours. In the second phase, lasting 200 days, flight mode is activated, disabling data transmission via GSM or LTE, as well as GPS logging. In the final phase, which lasts 20 days, the device is configured to send data once per day and log GPS positions every 6 hours. After verifying that all settings are correctly configured, the process is completed by clicking Load to apply them. At this stage, you can configure password protection for the device. There are 3 password levels: Config, Read, and Data. A config password ensures the device is protected from being reprogrammed or accessed without authorization. A read password restricts access to reading the data stored on the device to those who have the password. Using a data password means that when the measurement file is saved, a password will be required to open it. If certain password levels are not needed, you can deactivate them before proceeding. After setting the password, it's necessary to inform the device whether the battery has been replaced. In this case, new LSH14 battery have been installed. The next step is to select the installed battery type and confirm by clicking Use Selected Battery. Afterward, click Format to prepare the device. Once the parameters have been successfully downloaded, you can review them on the screen. These settings can also be saved to your PC or exported as a PDF document. When everything is complete, you can safely disconnect the device from your PC. Afterward, mount or position the device in its intended location following the installation instructions. Ensure the device is activated and verify its proper functioning by checking the status indicators. Additionally, confirm that the device can establish communication with the configured network or platform, such as GSM or GPS. Finally, check that the device is transmitting data correctly to your monitoring system or application. For more help, visit our support center.